Good morning, wonderful, amazing, fantastic algebra class. Today is Tuesday, March 17th, and I am posting examples on how to solve one-step equations, which was our topic for today. So let us jump into the assignment that is on Google Classroom, the hard copy handouts. So we're going to start with problem 3, solving one-step equations. So in problem 3, we are given the equation v plus 5 equals negative 9. Remember, to get a variable by itself, you want to use inverse operations. So when we're using those inverse operations, we are canceling this number and isolating this variable v. 5 minus 5 is 0. V plus 0 is just v. So we're getting that v by itself. We have to do the same thing to both sides of the equation to keep the equation balanced. So if we subtract 5 on this side, we must subtract 5 on this side. Negative 9 minus 5 gets us negative 14. And we're done. V is by itself, and we have found that v equals negative 14. That is problem 3. Problem 4 on the handout, we are given a minus 2 equals negative 5. Again, you want to use inverse operations to get a by itself. So because this 2 is negative, we're going to do plus 2 on both sides. So negative 2 plus 2 gets us 0. So a minus or plus 0 is just a. A is isolated by itself. Keep in mind we have to remember to do the same thing on both sides. If we add 2 on this side, we have to add 2 to the other side of the equation. So negative 5 plus 2 gets us negative 3. So our final answer for problem 4 is a equals negative 3. On the back, we're going to look at problems 7 and 8. So let us start with problem 7. For problem 7, we are given a different kind of operation. So our equation is negative 48 equals 4n. So keep in mind when a variable is written right next to a number, or a variable has a coefficient, this variable is being multiplied by this number. So this operation is multiplication. The inverse operation of multiplication is division. So that's why I'm showing division on both sides. We are dividing both sides by that 4 to isolate that n. Keep in mind 4 divided by 4 is 1. So we technically have 1n, which is the same thing as just n. Dividing by 4 on the, I believe that's the left side, yes, on the left side gets us negative 12. So negative 48 divided by 4 gets us negative 12. When you are dividing a negative by a positive, you do still get a negative number. So our final answer for number 7 is n equals negative 12. Also notice how problem 7 and 4 were different from problem 3 because the variable is on the other side, but the process is still the same. So do not let the side of the equation that the variable is on trip you up. The process is still the same. So now, lastly on this assignment, we're going to look at number 8. So problem 8, we have negative 9 equals x over 6. X divided by 6, excuse me. So when we are given a fraction in this way, x over 6, as I said originally, this sign just means division. So this is the same exact thing as x divided by 6. The inverse operation, or the opposite of division, is multiplication. So we're going to multiply both sides of the equation by 6. I cross these out because they cancel. 6 divided by 6 is 1. 1x is the same thing as just x. I crossed this out by mistake. So technically we are just doing 6 times negative 9, which gets us negative 54. There was no reason for me to cross this out because it did not cancel with anything on this side of the equation. So again, the trick with solving one-step equations, all equations really, is just making sure that your equations remain balanced by doing the same thing on both sides. So now we're going to look at the Khan Academy assignment for today, March 17th. I gave myself one of the problem sets that will be similar to yours, but again, these problems might not be exactly the same. If you have questions, you can comment them below or on Google Classroom, or send me an email or a text if you have any questions. So let's start with the first problem. I only chose, I think, 5 in the problem set. So the first problem for the Khan Academy set, first problem is 24 equals y plus 19. So remember, it does not matter what side the variable is on. You're just trying to isolate it regardless of what side it starts on. So the term or the constant that's on the same side of the equal sign as the y is the 19. So that's the term that needs to be moved. Because the 19 is positive, right? We have y plus 19. We want to do minus 19. Positive 19 minus 19 gets us 0. So this is canceled, it's gone, because y plus 0 is just y. Again, keeping our equation balanced, we have to do minus 19 on both sides. So 24 minus 19 gets us 5. So our final answer for this equation is 5. Keep in mind, you can always check your answer. So if you plug in 5 for y, we'll see 19 plus 5 does indeed get us 24, which means our work is right. So you always have the ability to check your answer when solving any type of equation. Problem 2, same process. I believe they switched the side. Yeah. So now it reads 19 plus 9 equals 30. The n is now on the left side, but again, that does not change the way that we approach this problem. Happens to be the same number, but I do want to note that this plus sign is assigned to this n, technically. So this is telling us that this is a positive n. Since there's no sign in front of this 19, it is still positive. So that's why we're subtracting 19. A lot of people tend to go by the sign that's right in front or right in between. So if this was a minus, they might think that this is negative 19, but you're always going by the sign that is in front, right in front, to the left, I should say, to the left of the term. So because there's no sign, this is positive 19, so we're doing minus 19 from both sides, which gets us 11. So n equals 11 for that problem. Problem 3, we have x minus 9 equals 1. So again, perfect example. This subtraction is a sign that is assigned to this 9. So this is a negative 9 and a positive x. Because this is a negative 9, we need to add 9 to cancel it. So negative 9 plus 9 gets us 0. This is gone. It's canceled. So x is the only thing remaining on that side of the equation. Again, keeping our equation balanced, we have to make sure we add 9 to both sides. So 1 plus 9 gets us 10. Final answer for this one would be 10. 2 more. Problem 4. So for problem 4, we have 6 equals k over 9. Again, when I'm saying over, I'm referring to this fraction notation. So k over 9 is the same exact thing as k divided by 9. We want to move this 9 so that the k is by itself. So the inverse operation, or the opposite of division, is multiplication. So that's why we're going to multiply both sides by 9. 9 multiplied by this fraction actually gets us this. I wanted to show you in a bit of detail what actually happens. So 9 times k divided by 9 actually gets us 9k divided by 9. We can reduce this part of the fraction by dividing by 9 again. So that would reduce to 1k over 1, which we know 1k over 1 is just k. So that's kind of a more detailed explanation of why multiplying a fraction by the same number in the denominator actually cancels. So we get k equals, and on this side we get 9 times 6, which gets us 54. So final answer for number 4 in my problem set is 54. Last problem is number 5. So for number 5, we have 9x equals 108. To get x by itself, when we have a number right next to a variable, recall that that is multiplication. So the inverse operation, or opposite of multiplication, is division. So we're going to divide both sides by 9 to get x by itself. 9 divided by 9 cancels to 1, or 1x, which is the same thing as x. 108 divided by 9 gets us 12. So our final answer for this problem is number 12. And that is all I have for the mini review on one-step equations for the March 17th assignments. If you have questions on any other specific problems, feel free to leave a comment down below, comment on Google Classroom, text me, or email me using that contact information that I provided in Google Classroom and I gave out the Friday before we went on our little closure. Also, feel free to reach out if you have questions about your grade or other things you can work on to improve your grade during this time. Thank you for watching, and I will see you later.